this year, there was a huge release on Ethereum that I'm sure many people here know about, which was account abstraction wallets. And these promise to bring very massive user X improvements to how users interface with the Ethereum blockchain, right? So some key features like sponsored transactions and programmable wallets really simplify user onboarding and how users can mint NFTs, interface with Uniswap or any other DeFi protocols, which is all great. What no one's talked about is how we as developers can also take advantage of these account abstraction wallets because of these same features. If you've ever tried to deploy a contract onto a test network, you know how painful that is, trying to get your faucet funds. Maybe not you get them, and maybe you don't even get enough. And this actually presents a vulnerability in your development workflow, because if you're unable to deploy to your test network, then you're kind of stuck. And so account abstraction helps here a lot. But being a new technology, you're guaranteed two things. One is you're going to have sharp edges, and two, there's never documentation for that corner case which you're trying to solve. And in this case, that corner case that we're trying to solve is deploying smart contracts with account abstraction. All the docs are around how you send transactions to mint NFTs and interface with other contracts, but nothing about how to create a new contract. So in this talk, I'm going to show you how you can improve your security posture of your smart contract development workflow by using account abstraction wallets. My name is Emil Basil. I'm a solutions architect at AWS, specializing in blockchain, and I'm also a JSR with Spearbit. Let's get started. It's a bit of faucet fun. If you've ever worked with faucets, this might look familiar. It's the promise of a big payout, and then ultimately, the faucet's not available, and you're stuck there twiddling your thumbs. Maybe you ping your one contact at the Ethereum Foundation, and they get back to you a week later, because right now they're in Istanbul, and they're not checking their messages. OK, so in this talk, I'm going to go on two tracks. We're going to talk about build and then deploy. If you've ever developed smart contracts, you're probably familiar with the build phase. But for completeness, I'm going to talk about build here. So when you talk about build, there's a few components that are always there. We need to compile our contracts. We always have unit tests that we want to run. And there's additional things that we want to do, right? Like we want to run code coverage reports, and we want to run static analysis, and we want to automate all of this, right? And the output of the build is most importantly our smart contracts, so the ABIs and the bytecode itself. And then you can also have reports and other things like that. So let's look at how we build a pipeline for this. So you start with your smart contract, make your changes, commit the code, and you push that to your Git repository. In this example, we're using AWS Code Commit, which is a private Git repository. This works just the same if you're using GitHub. Once that Git commit reaches your repo, that triggers your pipeline to run. And this is managed by AWS Code Pipeline. And this is an overall management service here. And Code Pipeline calls code build. And this is where all the logic is that we saw on the previous slide of building, testing, and everything else. And on the next slide, we'll get into more details on code build. And lastly, we output our artifacts, which is our contracts and our reports, into an Amazon S3 bucket. If you're not familiar with S3, it's a object storage. So you can put anything in there, and it's around very durably. So a bit about code build. It's a configuration that you define in a YAML file. And here I've highlighted two sections. The first is what we define when we want to build. So we want to compile, so that's forge build. We want to test. We want to run code coverage. And you can add lots of other things here. For example, if you want to run static analysis, you would run that in this part here. And then the bottom part is we define our artifacts. So this is the stuff that's going to go in our S3 bucket, right? So we've got our contract ABI, the bytecode, and any reports which we generate. So it's pretty straightforward. So we leave stage one build, and we have our contract ready to be deployed. So now how do we deploy it? Before we get into account abstraction, let's review how you deploy a contract with an externally owned account. So if you're deploying a contract with a MetaMask, what are you actually sending in that transaction to deploy the contract? So the key thing here is you don't specify a to field. And by not specifying a to field, you're telling the EVM that, hey, I want to create a contract, and it's expecting contract code inside the call data. So it knows that you're creating a contract, and in the transaction receipt, it prints out the contract address, and that's how you get your contract. So pretty straightforward. So now let's jump over to account abstraction and sponsored transactions. So for this example, let's walk through an example of wanting to add liquidity to a pool on Uniswap. So how do we do that with a account abstraction wallet? And the thing to remember here is an account abstraction wallet lives on the network, right? It's a smart contract wallet. So from the left here, we have our non-EOA signer. So this is anything that can cryptographically sign an arbitrary piece of data. So this could be a secure enclave on your phone, on your laptop. It could be a third-party service or a remote service. And a user operation, if you're not familiar with account abstraction, you can think of a user operation as a first cousin of a transaction. So when you use EOAs and MetaMask and all of that, you're creating a transaction. With account abstraction, you're creating a user operation. They have a lot of similarities, but there's enough differences where we're going to walk through them right now. So there's a lot of attributes that you send with a user op. The first one is the sender. And the sender is the wallet that is on the network that is going to execute our Uniswap mint call. So that's the user's smart contract wallet. And then you'd specify the destination and the call data, which you want that smart contract wallet to call. So in this case, we're calling this AA wallet and saying call Uniswap and call the mint function and pass the address. So all of this gets signed by the non-EOA signer on the left, and it gets sent into a mempool that is different than transaction mempools. And this mempool is managed by this off-chain entity known as a bundler. And the bundler takes your user operation, sends it on-chain to a singleton contract known as the entry point. And there's a lot of steps here that I'm just going to try to keep at a high level because we could spend a couple hours just talking about how account abstraction works. But most importantly, the entry point gets a user operation, does some validation on that, make sure everything is sound, and then it starts. It calls a execute function that exists on our smart contract wallet, and it passes everything that it needs to do to call Uniswap. And that's how it works. But the question is, who paid for this transaction? So the entry point by default is going to look at the AA wallet and say, you better have enough funds in your wallet to pay me, otherwise we're going to revert this whole transaction. And that's what we specifically want to avoid here, because we want to completely eliminate the need for our developers to have any need to have any currency in their wallets. So there's another entity on the blockchain known as a paymaster. And off-chain, we've gotten a signature approval from the paymaster that says, yes, I will validate this user's transaction. So at the end of this transaction, the entry point will actually get paid by the paymaster. And this is how sponsored transactions get paid. Okay, so now that we know how this works, how do we deploy contracts? So if you remember in the previous slide, we said you simply don't specify a to field. However, with account abstraction, you always have to specify a destination. It's part of the spec. You have to specify who you want this transaction to go to. So we spun our wheels on this for a bit, trying to figure out how to do this, and we built, as we were building out our solution, we were working with the Alchemy team, who was also building their infra at the time, and we came up with a couple of solutions, and I'm going to walk through both of those right now, and they both work, but they both have a catch. So the first option is we take our smart contract wallet, which exists on-chain, and we simply add a function to it that is called deploy. And this deploy takes your contract bytecode and it deploys it. Pretty straightforward. So how does this work? Your sender, again, is your wallet. Your destination now is also your wallet, because your wallet is going to execute the deploy. And so the call data that we pass is the deploy function call and the bytecode for the contract. And to take it to completion, we pass this to the bundler, calls the entry point, calls our wallet, which calls deploy, and that produces a user operation receipt, which is similar to a transaction receipt, but it contains all the user operation, because these are all internal function calls here. And inside of that, we've presumably emitted an event with the contract address, and that's how we pull it out from here. The downside to this approach is we're modifying our smart contract wallet code. So we're modifying Solidity code, and this is for a wallet. So there's a few things that are more important than making sure that your wallet is safe and secure. So if you're going to do this, you want to make sure you get a lot of eyes on it, do an audit on it, lots of things there. The second option is using this contract that Gnosis has already deployed called create call. And this contract exists solely to create contracts. Anyone can use it. So the way that this works is you load up your sender. The destination is this Gnosis contract. And you pass in perform create, which is the name of the function. You pass the bytecode, pass that through. That all works, and you get your contract made. So what's the downside here? So if you've ever worked with OpenZeppelin's ownable contract, by default, ownership of a contract is defined by the message sender. So who's the message sender in this flow? Who's creating the contract? It's Gnosis. It's a Gnosis create call contract, which is not who we want the owner of this contract to be. We want it to be us. So there's an easy workaround, which is if you're developing a net new contract, you can simply pass in the owner as part of the constructor. So you pass in yourself as the constructor in the constructor, and you set yourself as the owner. However, if you're using existing contracts, which assume that the message sender is going to be set as the owner, then you might have a little issue there where you need to update existing code or do something like that. So both options require some updates there, but we ended up going with option 2 for what we were building because we were building a net new contract. And so tying it all together, so when we left the build phase, we had our contract in Amazon S3. And we have now a remote signer, and in this case, we're using AWS Key Management Service. It's a very simple API-based way of sending some data and getting it signed, and so we can do that. But again, this can be many different things. And to tie it all together, we're using AWS Lambda function. If you're not familiar with Lambda, you can think of it as a function code that gets triggered on an event. And in this case, the event is our contract landing in the S3 bucket. So our contract gets compiled, puts into the S3 bucket, that triggers the Lambda, which then says, okay, I'm going to get the contract, I'm going to create a user operation, get that signed by a KMS, and then I'm going to send it to the bundler, send that off to the user operation, and then your Lambda can just poll for that user operation to complete so we can get the contract address. Or if you want to really save money, you can just stop your Lambda there so you're not paying for that time while it's polling, and you can periodically check for that user operation. So end to end, what we have here is our build and our deploy phase. So in the top left, we've started with our smart contract, and in the bottom right, we've automated this entire process without having to go get faucets, without having to refill our wallets, and you can run this for hundreds and hundreds of contracts as many times as you want without having to worry about testnet funds or anything else like that. You could even do this with production rollouts as well. It doesn't just have to be for testnets. So I'll leave you with a couple of links here. This entire thing came up for us because we were building a hands-on developer workshop where we needed hundreds of developers at the same time to deploy several contracts to the Gurley test network. And what we didn't want to do is start the workshop by asking hundreds of developers to go find Gurley faucets and try to get some funds. That is just not a great experience for anyone. And so as we were thinking through how to solve this problem, we had already created account abstraction wallets as part of the workshop. And so we said, what if we can use that also for deploying the contracts, for the administrative and operational side of that? And we thought it would be easy. Of course, nothing new is very easy, but it's always fun to sort of deep dive into that and figure out how to get it working. So in the top left, that QR code is for the workshop itself. There's lots of elements in there. We deploy a graph node for indexing. We work with IPFS. We build a UI. Lots of Web3 components there. And then the bottom right is the GitHub repository for this workshop. So if you're interested in what I've talked about here and you want to see the CI/CD pipeline and how we built our account abstraction wallets, that's all publicly available in the GitHub repo there. Thank you.